podcast for developers by developers, where we discuss technology and trends in industry. I'm your host, Tony Monkolsmai. This year, I've talked to several companies that are part of our Intel Liftoff for Startups program. That's just one of our programs that help startups. The Intel Ignite program is an internationally renowned acceleration program for early-stage deep tech startups. Launched in 2019, the mission is to fuel a global ecosystem of deep tech innovation by empowering a diverse network of founders, mentors, domain experts, and investors to co-create enduring industry-defining technology companies. Today, I'm joined by Ben Asaf, CTO of CLIKA, a company which has been part of the Intel Ignite program. Welcome to the podcast, Ben.
Thank you. Happy to be here. Thank you, Tony.
Yeah, so Ben and I actually met at an Intel Ignite, selection process meeting where we
Sure.
were kind of listening to kind of all the new startups that were coming down into the Intel Ignite program potentially, or were trying to become part of the program. You actually became part of the program through CLIKA. Can you tell us a little bit about CLIKA and what CLIKA does?
What CLIKA does is pretty much one serving API to compress and deploy models to a variety of hardware, starting from cloud all the way to edge devices and even microcontrollers.
So you're basically trying to right size models because nowadays everybody thinks of these models as big things that we've got to run in the cloud, but you're really talking about running them on smaller systems.
Yeah. There's definitely a pain point, and I can go very TMI about this. But as current trend goes, it seems like models are getting bigger. Sure, we all know that. But I think we're starting to converge into some understanding of what parameter size for models are, what they're giving you pretty much. So 7 billion, I'll be more explicit, seems like a sweet spot for a lot of things. More than that, well, you get to experience other things. But in general, yeah, so something got to counteract this trend by making things more efficient. Hardware can scale only to a certain limit until we have some kind of breakthrough. But yeah, software gotta keep up with all those things, and that's where we shine in pretty much.
So that makes a lot of sense. Can you tell us a little bit about what technologies you're using? So you package kind of all of these things together in a way that somebody can use it to optimize these models and right size these models. What types of underlying algorithms, technologies are you using that you can share with us?
Yeah, please. So there are lots of ways to tackle this. A lot of these things are already known technologies. For example, quantization. How do you map floating point values to integer values? Sure, granted. Pruning as well. Like, how do you decide what's important and what's not important in terms of parameter wise? And how do you remove those? Also, knowledge distillation as well. Basically training a smaller model based on a bigger model. There are all these technologies already in existence. But yeah, so what we're doing, what we're currently focusing on is quantization, which is, like I said, mapping floating point values to integer values. But there are better ways of doing this. This is pretty much an unsolved problem, similarly with how model convergence would work. Under different scenarios, you may have a better converging model. So in terms of the, let's say, core tech, quantization is pretty much available to anyone. But how can you do it better to preserve better accuracy? And that's pretty much the key here. How do you, let's say, lobotomize these models and still retain their performance in a way? So that's one thing we're focusing on, and we believe that quantization is already more than enough for all the general, like, let's say, speed ups that you can gain. On top of that, yeah, obviously, yeah, we have our own secret sauce. I should have mentioned that. But in terms of other things, there are also a lot of options to how do you fuse things, how do you get rid of things that may be considered freebies, and at the same time deliver a great user experience for the people who are using this. Because yeah, I can go into that more elaborately. I think we can cover this in detail, but maybe I'll stop here for this answer.
No, that's fine. I mean, we're happy to have you talk kind of free flowing about whatever the important technologies are. I do have a question about that though. So I think that a lot of times, especially in industry solutions, we find that people have done research and industry takes that research and then figures out how to integrate it into a product, productize it, ship it to somebody, etc. Are you guys doing your own novel research, or are you guys leveraging existing like research papers that are out there?
So that's a tricky bit. I feel like for a software company in general, patents can take you so much far. So we're keeping everything pretty much as trade secret because, well, once we publish our own findings, etc., like core findings, I think we can suffer from. And maybe that's an unpopular opinion in general because, well, patents generally work, and also for hardware products that would work very well, or anything that can be tied to a use. But we are keeping everything trade secret. We have our own novelty. I wish I could open source the entire thing, but yeah, so that's a limitation. But yeah, research definitely helps you understand what works, what doesn't work in general. I can say that we're not using any open source for whatever we're doing, pretty much.
Okay. And then as a developer, as somebody who is wanting to take whatever AI model I'm using and run it through CLIKA, am I basically taking like a PyTorch source code? Am I taking like model weights in some type of format and running it through CLIKA? What is the way that I actually get my model run through CLIKA to get this optimized model out the other side?
So currently we support PyTorch. We will expand this as well as we see more and more trend of use for certain libraries. Um, And so we currently support PyTorch. You put the model in. I'll keep it as easy as possible as explanation. You put the model in. It's a Python package. Front end Python. Back end is pretty much C++. Bindings between those, and everything runs on your computer. We don't see anything. We don't know what you're doing with that.
All right, so it's designed to be run locally. There's no like cloud service or anything behind it. In that case, I guess the question, an interesting question would be, is how long does it take, and what size models does it handle, and what domain of models does it handle? I know there's a lot of solutions that are very tuned for one type of domain and the other. And looking at your website, it looks like you handle a variety of domains. So if you wanted to cover that, that'd be interesting, I think.
So, in terms of model support, I feel like for me, that was the biggest frustration working with available tools back in the day because nothing worked like I wanted to. And every time I would experience those hurdles, that would just keep me back. And I see myself out of nowhere spending 2 weeks of trying to make something work like I wanted to because, well, so that's that's where we said like, okay, well, I mean, if the experience is not great with those tools, how can we make it better? So we decided that we'll build a compression SDK pretty much that would enable you to just have one API to just get to either NVIDIA hardware, Qualcomm, CPUs like Intel, AMD, etc. Like it just seemed like the natural choice because as I was frustrated with that, it just like kind of like made me angry in a way because I couldn't believe that I'm spending too much time on that. So in terms of model support, yeah, our focus was pretty much supporting whatever comes, and at the end of the day, like those models are nothing but a graph, a fancy graph, I guess. Equivalent node is a layer, edge is where the tensor passes to. Uh, so we just try to look at every model like as such because that way you don't care about specific architectures, you don't care about anything. You just want to enable creativity as much as possible without hindering them. um, and at the same time, part of this is also bridging upon, like, let's say, a lot of frameworks. Sure, there are lots of open source tools to do quantization, but the thing is, what if a certain operation is not supported? What would the user do? And what I find lacking a lot is, well, I can express this operation as two operation. Why don't they do it for me? And I mean, it's just small example, right? But this thing adds up, and user have to resort to manually doing those things, and especially companies that deal with a lot or diverse type of hardwares. I don't know, they have cloud, they have mobile device, they have like those two already. You have to learn two tools minimum in order to get there. And it's frustrating. It definitely increases the technical debt that a company may face. Definitely adds us more complexity. And I felt like, if we don't own this, let's say, supply chain from user having a model that he's happy with and getting to that hardware is pretty frustrating. So this is for us is just like the first step, pretty much just starting with this to enable much more diverse applications and tools, etc.
Okay, and that makes a lot of sense. And the next question I have is you mentioned kind of that you can run it locally. Um, are there any hardware requirements? Like my first thought, and probably just because what I've been thinking about lately, is like, would you ever have this be kind of like a cloud service where somebody comes and gives you the model, and then you run it through CLIKA and then give them the model back, and it's a cloud service that you continually run rather than having them download it? Is that a business model that makes sense for you, or is it makes more sense to allow people to kind of experiment on their own systems?
Yeah, that's a good question. We're getting asked a lot about what do you think about SaaS and how do you plan to make this into SaaS. So most companies we talk to are very sensitive to either the data and the model, but mostly the data, I would say. So that pretty much disqualifies a lot for SaaS use. Now, if we're talking like, let's say, developers just by themselves, not working for a company, I guess that would make more sense. But then again, what would the toolkit that runs locally on your machine wouldn't solve? I guess like I wouldn't say we're aiming as of now for the general, like, let's say, business people to do compression. I don't think that's where our tool shines at, um, at least as of now. But no. So having the SDK just work natively in their machine, it just feels like the natural choice. And also because machine learning is so diverse in its applications and how people apply it and certain rules and certain training loops and how they read the data. I mean, who am I to dictate a certain type of rigid structure that, okay, drag the model here, drag that. I mean, there are lots of subtleties to how people train those and do the. Obviously, a lot can fall into the generic kind of looping and sure, but for people who want more, I feel like that SaaS is not the answer necessarily. Obviously, yeah, I can go creative and say, yeah, maybe we can somehow upload the training code into this and do that, but then you run into security problems and yeah. Like, sorry, I'm wearing still my CTO hat and I'm just thinking about. But yeah,
No, that's
that the
great.
gym. Yeah,
Our audience is supposed to be developers. They are going to
that's
want to
awesome.
hear all of the thoughts and the thought process of how you design and engineer your solutions, because that's at the end of the day really important, because like you said, you can make things easier, you can create SaaSes, and I think that there's obviously tiers of customers and developers that you would care about. There's the customer that says, I want everything to be easy, give me a drag and drop, just my model's going to run through here, I don't really care about digging in and really playing with it. And then
Right.
there's going to be really I don't want to say hardcore developers because that sounds like I'm shortchanging the other developers, but the developers who just want to tweak all of the knobs just to see
Yeah.
what happens, right?
Yeah.
It's not I want it to be easy and fast. It's actually I want to see how do I get the best solution out of this. And I think that it sounds like you're targeting those developers, and it kind of makes some sense because you're talking about an optimization framework. So they obviously probably want to get the best optimizations they can out of it. And the other interesting thing was I looked at your website and you were talking about how ClickUp performs against other frameworks. So you had NVIDIA frameworks, you had Intel frameworks, and showing kind of like the loss degradation in terms of accuracy running through ClickUp versus other frameworks. I was impressed by that. Do you want to talk about that a little bit?
Yeah, I feel like it always feels like kind of a guilt, but yeah, we're obviously we're trying to show that, like, there can be better. There can be better thing, and I think especially with very performance sensitive wise. Let's say you're a stock trading firm. Okay. And you're trading volumes of like millions of dollars. Would you feel better if I tell you, hey, I have a 90% performing model, or I have a 97% performing model? Where would you feel more comfortable putting your money at? So that's kind of thing. And also for anything like sensitive, let's say, sensitive autonomous driving, sure, this is an unsolved problem. Every accuracy matters, and that translates to safety directly. So anything that needs cutting edge needs high accuracy retainment. And you'd be surprised. There are lots of frameworks that still don't support the latest things, or only support it within a non, let's say, production in mind. And yeah, this word production, what does it really mean? It means actually putting it into the environment that it would perform in. And a lot of these tools focus on Python for a lot of things. Maybe for cloud, that's fine, but a lot of the things actually go into high performance kind of pipelines that it matters. So the, the reason also we wanted to build this from scratch is because I had a lot of weird ideas of what may work and what may not work, and I was confined into something that pretty much like forced me into a certain type of thinking and dealing with other people's problems in terms of engineering, I mean. And I just like had to do it myself. Like this, I guess it makes sense.
Yeah, and you mentioned you talked about automotive, and I know that you a while back worked at Mobileye, which was which is an Intel company which does automotive and is researching things like autonomous driving. Really, that's what their bread and butter is. So then let's shift gears a little bit and talk about how you went from working at Intel and then how you ended up founding a company and becoming the CTO of a startup. I think that that's always one of the things that I want to touch on as I talk to people who have kind of created these new companies and trying to, I guess, unlock value in places where they see gaps. So can you talk about that a little bit and maybe about how the Intel Ignite experience actually helped you as well there?
Okay. Yeah. So I used to work at Mobileye. I was working in the object detection team, and my job pretty much was to create tools and make things more efficient in terms of how people develop models and trying to reduce any waste, making things more efficient. So even like someone that is a recent graduate or not even hired, not even graduated, like let's say he just finished machine learning course, super bright person joins the company, he doesn't need to know about certain, let's say, practices of what is best and what would work on the final hardware, etc. Like they don't care about this, and I don't think they would have the capacity to absorb all of that without making mistakes in the way. And mistakes are fine, but at the end of the day, there's a very clear goal, and we're trying to make everyone orient to it. And just how do you make them as valuable and make them express whatever they have on mind of trying to improve the final solution like the others, like not like pretty much trying to undo their initial handicap that would probably be solved in, I don't know, 3 months of onboarding, trying to understand how things work, how things flow. So part of my job is making this much more, let's say, frictionless. There are lots to talk there. But overall, yeah, so I think my personal story is a bit unique in how it came to CLIKA eventually. So I moved to South Korea like 3 years ago. Uh, I am married to Nayol, which is a Korean person, and I mean we did not plan to establish CLIKA, but we just out of nowhere, we said, well, there are lots of things that I want to develop. I want to do a lot of things. Let's just apply to this Korean government program. If we get accepted, let's do it. And I mean, I'm giving you the short story, but obviously there was a lot of pain in that process because she helped me prepare for like a seminar, and she saw potential, and her background is business related. So she worked with over 100 companies and helped execute. like multi-million dollar projects, very diverse kind of experience. So we just said, yeah, let's do it. We got accepted and we went for it. We started obviously very, very small, very small. We were located in a city called Gwangju after a while, which is in South Korea. Um, and we just kept growing. We kept hiring. We're now 12 people, still small, but we were looking to expand to US because, well, US is the biggest market pretty much for what we're doing and the most technical savvy people. And part of that was, how do we expand our network and how can we get to know more people? How, what do we do? So Intel Ignite seemed like a very, very natural choice. And we actually applied the first time, we got rejected. And we applied for the second time and we got accepted. And we got to know incredible people. We got to know like our cohort members, previous alumni. We got to know the Intel Ignite team. It was amazing, and we're really thankful for that. Yeah, that helped us tremendously, getting the exposure and it just everything we wanted, pretty much.
That's great. So they really help you build those business connections, and they have the best swag at Intel. So I've got
Yeah,
my Intel Ignite hat.
yes,
I've got my Intel Ignite shirt on for this podcast.
yeah.
So I knew we would be talking about Ignite, and I knew that Zach would be excited. So Zach, who leads our Intel Ignite program, I knew he'd be excited if we could put some of the swag in here so other people can see it.
Do you have the coin though? Where's
I don't have the coin. No, so maybe you have the coin. You can show the coin, and we'll show that off on the video as well. Because this is actually our second video podcast. So I'm trying to take advantage of all the cool things I can do now
the
that I couldn't do
coin?
before. Oh, nice. So
Uh,
apologies to the people who are listening to this on audio. You just got a 1 minute thing as we talked about things you can't see. But then go check out the video podcast on YouTube, and you'll be able to see it there. So yeah, so looking forward then. So you've got CLIKA, you've got 12 people. You're trying to run a company, and you mentioned, your wife, who's actually the CEO of the company,
yes,
right? That's
that's true.
correct. Yeah. So you mentioned her. So you've got all these things on your plate. You travel. I think you travel between what, Korea and the U.S. still? Is that correct?
Right now, yeah. We're ping ponging between those. We're looking to move indefinitely to US and make the company successful here.
What areas of technology of interest to you going forward? So obviously you're in the AI space. You are using you have this SDK, this framework for trying to optimize CLIKA, optimize models using CLIKA, right, to make them fit onto systems. That makes sense. What's the next thing are you using AI as part of your development process? Are you looking at new areas in AI to expand beyond where you're doing right now? What kind of excites you? What's an area where you'd say, wow, that's an area that is super interesting that I'd really like to get into, whether it's with CLIKA or something else? What excites you as a developer?
I I was always driven by trying to make process easier. Even like in university time, I would be the first one to finish the assignments in my class, and I would just create software suites, like just for everyone to test their software, their assignment. No answers, but just like a way for them to validate if it's working or not. And it even came to a point where I created, let's say, a mini syntax that you can create, like letting them express their own testing ideas and just share a text file that they just put in the same. So I mean, I was always motivated by that, and I think there are lots of pain points with machine learning in general. So, what really excites me is getting things working efficiently and making it easy, because I mean, just by the sheer amount of research that comes out, new architectures, new tricks, it's a lot, and that is one fight, and then getting the things to work is another fight. And probably there are like three, four more examples of issues that just keep popping. So I think our mantra is pretty much make ML development easy, and as first milestone is making compression easy. Just pick the hardware. Don't worry about it. That's all you have to do. Pick the hardware, you're done. It would work. Um, and I mean, in terms of Gen AI, etc., I think honestly, I don't like the fact that everything just keeps getting bigger and bigger. It just seems like throw more compute at the problem and wow, it works, but at what cost? And there are lots of marginal things that just add even more difficulty. Obviously, it's super cool that these things work, and probably that's the right direction to get even more like fancy things coming out. I think it's just like a stepping stone, though. It will not end here. There would be a better things that would come out. And honestly, I'm very interested in seeing what kind of hardware would come out. Like what kind of things? Sure, like memory performance increases, HBM 4, 5, whatever would come out, that would help tremendously. And but I feel like the way that things work as of now is just like something we have to go through. Just throw more compute at the problem. Yeah, Gen AI is exciting. Yeah,
I think that the interesting thing there is that for a long time, right? Like neural networks were obviously been around for decades, and then we didn't really have the hardware, or in the case of where we're at now, kind of the network design for the models to make them useful,
yeah,
even with larger amounts of compute. And now that we've kind of unlocked it a little bit, we took that step forward where if you actually have more compute, you can solve these bigger and bigger problems. So that's kind of the way that we've gone. Whereas before it was like, okay, I will never have enough compute, so I need an optimization. So we came up with that optimization, right, in
yeah,
2012, and we with the ResNet, and now we're saying, oh, now I have a new algorithm, so now I can actually have enough hardware to solve the problem. So I'm going to continue down this path, needing more and more hardware to solve the problem, but using
yeah,
similar network layouts. And I'm sure somebody who's doing research here will hopefully correct me and say, no, here's all the novel things that we're doing, but it's still on this, like you said, this kind of exponential scale of I went from,
yeah.
like a 70 billion parameter model to then it was like 200, 300, and we
Yeah,
thought this
there's
is
even one
crazy.
trillion. There's like one
Yeah,
trillion Megatron, I think. Then a Megatron, LM,
yeah,
Turing,
Megatron.
whatever. Then yeah,
Yep, and
insane.
we were trying. I was at Habana when we were trying to get it running, and it's just yeah,
Oh
that
my
makes
god.
sense. And then, but the question is, at what point does that not scale? What is the next thing that actually will make the problem tractable in terms of how we can compute? Because there's never going to be enough compute. It's amazing if we follow this path. It seems like the human brain, right, that we all have in our heads, can
Yeah,
do a lot of these operations with error because we don't have this long chain like you have in LLMs, right? How many tokens can I have in input? Now we're talking about a
yeah,
million tokens. The
yeah,
human brain, I've got all these things in my head. I can build all of this context over my life. It all fits in
yeah.
my head. But somehow I need a model that takes trillions and of parameters and hundreds of hours with the world's most powerful hardware to make it even functional.
Not
Which means
even
there's
that.
something
Yeah,
algorithmically wrong with how we're doing it. It's just, in some
yeah.
sense, it seems like that at least.
And even to humiliate the compute and what our brain is capable of doing against that is just, when you're driving, you're even spacing out, but you still drive perfectly. You know what it's just like a background thing. You just don't think about it. You're still driving, and it's amazing comparing these two, how intense the process. And then like you just had an apple. It's incredible. I wish, I mean, maybe biological kind of hardware would be like a natural thing to do, pun intended. um yeah, like it's yeah, I wish it would be more efficient. And I had conversations with senior programmers, like people who worked with assembly, raw assembly back in the day, and we were talking about how intense compute is now being used like reluctantly. And I think if there was some kind of a hardware limitation, because you can still throw compute at a problem. Sure, Nvidia maybe will. I don't know how they're manufacturing now, how well it keeps up with the demand, but there is obviously a demand that is not met. So maybe if developers were more constrained, that could have been better for breakthroughs, I want to say. But
Yeah, and we may be getting there. Stability AI released a blog around Intel Gaudi AI accelerators where we talked about the scalability of that. And those were really designed for scale up and scale out in a from the ground up, right? Which I think is because they came around in the age of already knowing that what I want an AI algorithm to look like. So they could be designed to be more specific. There's other companies out there as well. Cerebras just taped out their gigantic chip, which is like a wafer on a chip, which is really cool. But yeah, all of these hardware innovations, I think, are really great, and they're targeted at the software and the algorithms that we have today. But that's like you said, if we actually were forced to try to make another innovation, it is interesting to wonder whether or not we would have been able to do that already around how we're doing it. Because, like for instance, I know like in neuromorphic computing, it works way better for robotics than a deep learning big model because it just has different characteristics. It has different input parameters than the way we build our traditional AI models. So I definitely think that that is a good question to ask ourselves whether the technology we're building is limiting us a little bit.
yeah, that's really exciting. I think we're living in a very interesting time, as cliche as it sounds, but like everything is booming. The hardware is advancing super quickly. Intel is like making insane moves on terms of hardware and what they're trying to do. Um, I I mean, I have no idea how it would go. Honestly, NPUs sounds promising. I wonder how that would scale to, let's say, cloud compute kind of thing. How hard can it come? Like you had experience working on these?
I have so I've used them. So I've got the Intel Core Ultra Meteor Lake
Yeah. Okay.
system right here that has an NPU on it, and I've played with it. And I think that the key point there, again, it's a purposeful design for some type of AI workload. And in this case, it's really less about like top end compute. So when we talk about the Intel Gaudi AI accelerator, when you talk about NVIDIA solutions or even AMD solutions, they're worried about top end compute. And with the NPU, it's really about bringing low power compute to systems, right? So within the laptop space, in the mobile space, we really care about what's your battery life. I had a really great professor at the University of Illinois, Wenmei Wu, who really he said when in the early 2000s he was like, I don't really care about laptops or phones until I can use it for an entire work day and then plug it in at night. And once I can do that, my problem is solved. Then I'll use it all the time. And that definitely came to pass, and he was very prescient on that. But then on the other side of the things, with the NPU, if I want to run these AI algorithms all day, if they are compute intensive, it's like trying to play a video game on your laptop all the time. We know gaming laptops, they last the top end ones last 30 minutes, right?
Yeah.
I can get an
Yeah.
an Alienware laptop or a Razer laptop. It's going to be dead in 30 minutes, and it's great because it's portable, but it doesn't get the job done what I need. So bringing in the NPU allows you to run these AI workloads at a lower power for a prolonged period of time. So now I don't just use Stable Diffusion, for instance, or an LLM on my laptop for 30 seconds. But what I really want to do is have that experience of running in the background all the time, the same way that you would get out of, for instance, something like your iPhone with Siri or your Echo from
Yeah.
Amazon, right? Having these smart AI things listening to you, if that's what you want. I guess I'll preface with
Yeah.
that.
Yeah.
Always
That's
listening
kind
to
of
you,
yeah.
trying to
Totally true.
tailor the experience to what you want.
Yeah.
All right, so we're almost to the end of our time here with Ben, and so Ben, I'm going to ask you the question that I ask almost all of my guests, which is, where do you hope technology is going to take us, either as a society, specifically around CLIKA, whatever it is? Where do you hope technology takes us in the next 5 years?
I am very interested seeing where does Gen AI converge to, or what would be the go-to applications that are actually practical, not just fun. And there are already signs of maybe potential convergence of that, especially with coding assistants. Sure, that's actually useful. Uh, LLMs for just chatting, debatable. Like it can help for other things, but I don't know. I guess like everyone can make a lot of value from this, but I'm curious to see where it can be used to boost efficiency of things and maybe just enhance our daily life kind of, I don't know, functionalities. I'd be happy if I could, for example, just could look at something while I'm driving and ask what is that, and actually have that, or just having a full-fledged assistant that can help me schedule my day, for example. So I think it's still early in that regard, and in terms of safety, etc. I wish to see better hardware, and I mean not just throwing more compute at a problem. That is something that will happen. Things get more efficient, plenty of new accelerators, probably more memory bandwidth. I'd be happy to see something very unique, something out of nowhere that helps like treat like LLMs like we treat driving with our brain, pretty much. Like, you know what I mean? Like, just makes it seem so casual, like as if it's non-existent. And maybe like, you know, potential kind of architectures that actually make sense instead of stacking more layers to a model and saying, okay, this marginally better, half percent better, and you made things worse by having a, you know, you need to throw two more Gaudi accelerators at the problem or something like that. I wish there would be something truly revolutionary in terms of like hardware design, architecture design. In terms of CLIKA, I think, I mean, we will expand. There are always there are so many AI chip companies as well. Supporting those would be one thing, but also we would be expanding our reach to other kind of problems within like ML development, or what people like to call ML ops. Um, so that's in terms of CLIKA, but I'm really curious as a very like as a developer, like what will I be able to use in 3 years? I honestly, I'm super excited for that. Can be horrifying too. Not gonna lie, like how things might end up. But
All right. Well, thanks, Ben, for joining us today.
thank you, Tony. It was fun.
And thank you, our listener, for joining us, and our viewer, if you're watching us on YouTube. And join us next time when we talk more technology and trends in industry.